Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a nice equation with complex numbers, which we're going to be calling this a locus problem, and I'll explain why. So we have the absolute value of 2 times z bar plus I equals 4. So we have a complex number z, and its complex conjugate, which is z bar, is designated by z bar, this symbol right here. And we add I to it, and then we take the absolute value. So we're looking for numbers, a bunch of numbers that satisfy this equation. And there's usually more than one. Sometimes there are no solutions, sometimes there's a single solution, but we call these locus problems because usually the solution set to these problems will make up a curve, like, either a straight line or some type of curve. That's what we call a locus. Okay, so let's go ahead and focus on the locus and see how we can solve a problem like this. Okay, so since this is a locus problem, I'm going to go ahead and replace z with x plus yi. And the complex conjugate of z is defined as x minus yi. And why is that called the complex conjugate? Because when you add z and z bar, that's going to give you a real number, right? Because the yi is going to cancel out. When you multiply them, it's also going to give you a real number from difference of two squares, which turns into a sum of two squares, right? So x squared plus y squared in the complex world actually can be factored out. By the way, if you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, and trigonometry problems, go ahead and check out my other channel, Cyber Math, Cyber with an S. Okay, great. So let's go ahead and see how we can use this information to solve this problem. Wait a minute. If we don't have a z in the equation, that's perfectly fine. Our goal is to replace z bar, whatever, is with something we can do. And then at the end, we're going to find an equation. And that equation curve, whatever function, that represents our locus. Okay, so let's go ahead and do this. We're going to replace z with z bar, so it's going to look like this, x minus yi. We're going to add I to it, and then take the absolute value, and we want this to equal 4. Easy, right? You just replace z with x plus yi, z bar with x minus yi, so on and so forth. Great, let's go ahead and simplify this. Paying attention to the fact that this is an imaginary part, this is another imaginary part. We're going to put those two together. So we can basically write it as 1 minus 2y as the imaginary part of our complex number under or inside the absolute value. Okay? Now, how do you find the absolute value of a complex number, right? Let's go ahead and define it. By the way, the name of this channel is A plus BI, which kind of makes sense, right? Okay, so the absolute value of a complex number like A plus BI is the square root of A squared plus B squared. In other words, it's defined as the distance from 0. So if your number doesn't have to be in the first quadrant, but all quadrants will work. Basically, if your complex number is A plus BI, then its absolute value is the distance from 0, which you can designate as absolute value, or you can use R, and it's also called modulus. Again, I go over all of these in lecture videos. Go ahead and check them out and ask questions. If you don't understand something, feel free to ask. So let's go ahead and apply the formula for absolute value of a complex number from distance formula, or I should say the Pythagorean theorem, to this scenario. So we're going to take the square root of the real part squared plus the imaginary part squared. And we want that to equal 4. Easy, right? Let's go ahead and expand it. And what happens, first step should probably be, doesn't have to be, but I think it's better if you get rid of the radicals. Square both sides, you're going to get 4x squared. By the way, you can just do two things at a time. Just get rid of the radical and expand this. It's going to be 1 minus 4y plus 4y squared equals 16. Awesome. Now, what do we have? What does that look like to you, right? Is it, well, it's called a conic section. So when you take two cones that are kind of facing each other from the vertex, two cones like on top of each other like this, okay? You have two cones, and you kind of intersect them with planes at different levels. Like if you make a horizontal plane like this, the cross section is going to be a circle. If you slant it, it's going to be an ellipse, so on and so forth, right? You get those conic sections, hyperbola, parabola. Which one is this? That's going to be the million-dollar question. First of all, notice that we don't have any term with an xy. That's a good thing. So Let's go ahead and rearrange these terms. I'm going to go ahead and bring the 4y squared here, and then follow by minus 4y. And since I have a 1 here, I should probably subtract 1 from both sides. We want to leave all the constants on the right-hand side because we're going to be adding anything to both sides anyways. And when we do, it's going to be for completing the square. Does that make sense? That's the whole purpose. Well, maybe if I didn't expand it, things would be better, but I'm going to show you. We're kind of going back and forth with this, but guess what? Sometimes you'll just get an expression like this, and you need to be able to manipulate it. So I'm going to show you how to do that. So we're going to go ahead and add 1 to both sides. And the reason behind that is we want to make this a perfect square. It actually was a perfect square before when I didn't subtract the 1, but one more time, this is going to be a perfect square. And by the way, if you want to make this a little interesting, let's do that. So we're doing something slightly different here. Let's go ahead and divide everything by 4. How about that? Because that's going to be cooler. And when we do that, we're going to get 15/4. Now, here's the challenge. You need to add something to this so that this becomes a perfect square. And the idea is you look at the coefficient of y, regardless of the sign, doesn't matter plus or minus. It's 1. Half of 1 is 1/2. Square it, 1/4. So that's what you need to add to both sides. Let me show you. X squared plus y squared minus y plus 1/4 equals 15/4 plus 1/4 is 16/4, which is 4. Beautiful. Now, why did we add 1/4? Because it makes it a perfect square. And it's just perfect, right? Like this. Look, y minus 1/2 is a perfect square. Now, there's a lot of advantages of writing it this way. By the way, I'm going to show you why. But if you did it the other way around, like just take this and then complete the square, it's already complete, by the way, you would probably need divide both sides by 4 at the end, which we already did, right? Here we go. Now, this represents a circle. Ta-da, surprise. And what kind of circle is that? Its center is at 0, 1/2, and the radius is 2. Why is that happening? Let me show you the general equation of a circle so you can deduce for yourself. This is the circle whose center is h, k, and whose radius is r. So it's given by 2 parameters or 2 things. Actually, in this case, it's 3 parameters. But this is our circle, and that's our locus. So let's go ahead and take a look at roughly try to graph it. Center is going to be at 0, 1/2. So 0, 1/2 is something like, if this is 1 unit, this is going to be 1/2 unit. So our center is going to be here. And our radius is supposed to be 2 units. So we're going to go up 2 units this way and 2 units that way. That basically puts us as 2 plus 1/2, which is 5/2. So it's going to be like 2.5. If this is a 3, this is a 2. Our circle is going to go through this point. And then if you go down, it's going to be like 1/2 minus 2. And that'll be negative 3/2. So it's like negative 1.5. This is 1. This is 2. So something like this. So our circle is going to go through all these points, something like this, right? And see if I can make it a circle with my superpowers. Oh, it didn't work. Because Desmos, obviously, I mean, not Desmos. What am I talking about? Is this Desmos? No, I don't think so. What was the name of this app? I forgot. Notability, yeah. So something like this. Anyway, you get the idea. This is a circle whose center is given. And it's such a lousy circle, but you get the idea. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out CyberMath and aplusbi. And bye-bye.